Wonderful. All right. So now we go to the second part where we are looking at kind of the general question of how do you apply mathematics and technology to humanities? Because our group is mostly focused on humanities, and we try, I mean, but it is unique in the sense that we think that science and humanities go together, in the sense that you can take principles from science and try to apply it to humanities, and we're very much kind of trying to take everything from evolution, for example, and applying to humanities. But you have done a lot on kind of mathematics and technology. You brought those two to bear on humanities. So can you talk a little bit about that?
Yeah, so the way that I think about it is there are certain powerful ways of figuring out the truth about the world. And I want to master all of those powerful methods because my life's mission is to try to find ways to help improve people's lives. So I want to try to become a master of these different tools. And being a naturally very technical person, I'm going to tend to lean on the sort of technical tools, but try also to learn the more qualitative, more subjective tools as well, because I think they can be really helpful. So from the way that I operate is I want to understand how to, I want to think about it like I've got this big toolkit, and then these questions I want to understand in the world, right? I want to understand, why do people become anxious, and what can we do to make people less anxious, for example? Or I want to understand, why do people fail at setting goals or not achieve their goals that they set? And how can we help them? So these are kind of the kind of questions that I'll be after. And then I'll say, okay, I've got this tool belt. What are all the tools that I can use to try to help me answer these questions? And it's a huge range of tools. And each year I try to add more tools to my tool belt. And then you have to not only master the tool, but try to understand, when do you use that tool versus another tool. So just as an example of some tools in the tool belt, one of them is go read an academic paper on the topic, or go read 20 academic papers, right? So, but that's just one tool. Another tool is go talk to an expert. Experts are often actually surprisingly approachable because most experts are not famous. You can just email them and they might respond. You maybe have to email 3, but probably one of them respond. Another tool though is doing data analysis. So maybe I can find a data set that has information about that topic and I can analyze it, or collecting my own data. So I've started running lots of studies. We run studies all the time now because it's such a powerful way to answer questions. And we actually built technology like our system called Positly, and another system we built called Guided Track that helps us run studies quickly. So if we have a question like, okay, so here's a question, example question we were trying to grapple with. Do depressed people know that they're depressed, right? So what we did is we ran a study where we measured how depressed people are using kind of standard methodology. And then we actually asked people, do you believe that you're depressed? And we found that about 2/3 of depressed people believe they're depressed. And that's really helpful information, because if we're building a product to try to help people with depression, we need to know how to talk to them about that product. And if most depressed people didn't know they were depressed, we can't use the word depression because they're going to think, oh, it doesn't apply to me. We found, in fact, the majority do. So that's just an example. But there's just so many tools in this kind of tool belt of like discovering the truths about the world. And I'm just trying to master them all. So that's my approach.
Okay, how did you get on this path? Where did you start? What was the first thing that you really got into, and how did you grow? What's your history in pursuing this path?
Well, I think for some reason, ever since I was young, I always had the goal of trying to make a huge positive impact on the world. And so, what's been the growth area for me is first of all, learning many different skills, and then also getting much clearer on like, okay, what kind of impact do I actually want to have, and through what methods. And basically, over time, I decided that I was going to focus on social science, and more specifically, the social science of everyday life, whether it's, depression or anxiety or goal setting or decision making or habits or these kinds of things. So that's kind of in my focus area. But really for me, this is just my attempt to answer the question, how do I help improve people's lives in a scalable way where I can hopefully affect a large number of people.
You studied mathematics, right? I mean,
I did. Yeah, I have a PhD in mathematics. Yeah.
So tell me about the use of mathematics. What is mathematics? And because what happens is that most people don't have a sense of what mathematics is, because they have a much more kind of a surface level understanding of it.
Right.
So what is mathematics, and what is its role in trying to understand the world?
Yeah, that's a great question. And I think it's something people are very confused about. In part because the way math is taught in middle school and high school a lot of times, it feels like what math is when you're taught it is there's these extremely formulaic problems, and then what math is you crank through an algorithm and it solves that problem. But I think that's a very like superficial way of looking at math. What I would say math really is, it's a language of patterns. And so the way that you really use math is you look at the world, you notice a pattern. You then use the language of patterns, which is mathematics, to describe the patterns you see. You then you take this language of patterns, and now you have described this pattern in the world, and now you can use the power of math to manipulate and learn new things about the pattern you didn't know before. So that's where that math gets really interesting. It's like, so let me just give an example and make it more concrete.
Mm-hmm.
You're trying to study traffic flow in, cars flowing through a city, right? Because you want to reduce the traffic in a city, right? So what do? Well, you start writing down equations that describe things about traffic. For example, you know that the number of cars going into an intersection has to be the number that eventually leave, because cars don't just vanish into thin air, right? But other things do vanish into thin air, right? Like water evaporates, but cars don't evaporate, right? So you start writing down facts about the patterns of traffic, and you can actually describe them. In this case, you can actually describe them using what's known as a differential equation. So that's the piece of mathematics, the piece of the pattern language you use to describe traffic flow. Once you've described the traffic flow as a differential equation, you now turn your attention to that pattern itself in the mathematical language. So you look at the differential equation, and now there's a whole bag of tricks you can apply to the differential equation to understand it better. You can actually derive things about the differential equation that then teach you about traffic, teach you things you never thought of about traffic.
Mm-hmm.
And then you go and check that they actually work in real traffic, because it could be that the pattern, you didn't quite get the pattern right. And whenever you use math as a pattern language, you're always oversimplifying, right? You're never describing absolutely everything. You're never describing, you're not describing the wheels that are turning on the cars, right? You're trying to abstract away. So you have to go check in the world to make sure the pattern is correct and actually describes closely enough the thing you're studying. So that's what mathematics is, really.
Wow, that was excellent. Let me ask a question in a slightly different way. So
Sure.
The way I found is that there is like a science culture and there is a humanities culture. Mm-hmm. And there are very few people who can go back and forth between them. Like the science people focus on scientific issues, they're very good at that. But whenever it comes to humanities, they don't actually use the same tools that they use in their technology or their science into humanities. And humanities people are kind of very suspicious of the science or math. So what is it that science has to offer to humanities, and what is it that humanities has to offer? So first, let's take what does science and mathematics have to offer to humanities? And then I will ask you the second question. Go ahead.
Sure. So what does science have to offer the humanities? I think a few things, or quite a few things. One of them is measurement, because one of the problems with just focusing on the humanities is that you're not measuring anything, generally speaking. And if you're not measuring anything, it's hard to know that you've really done something, right? If you imagine that scales didn't exist, how do you know if you lost weight? Well, maybe you can tell, but maybe you're just deluding yourself, right? But now you have a scale and you say, oh, no, I actually weighed 10 pounds less than I did before. Okay, I've done something. Something's happened. Something's changed. So that's one of the really valuable things about science. Another really valuable thing about science is this idea of randomization. A lot of people don't get the power of randomization. I'm going to contrast two things for you. The first is, imagine that some days when I feel like it, I drink a tall glass of water when I wake up, and other days I don't, right? Compare that to every morning I flip a coin, and if it's heads, I drink a tall glass of water. If it's tails, I don't. In both cases, let's say I actually make a measurement. Let's say I track how tired I feel throughout the day, right? The beauty of the randomization is that because the coin flip is random, I can actually measure whether the glass of water affected how tired I feel. If I instead of randomization, I just decide whether to drink a glass of water every morning, the problem is there may be factors that are affecting whether I decide. Like maybe when I'm more tired, I don't feel like drinking water or something like that. That's going to create an artificial correlation, and I'm going to come to the wrong conclusion. So randomization is this incredibly powerful idea from science. And really, the power of randomization is it allows you to infer causality. It allows you to say not just A and B are associated, but A caused B. And that's one of the most powerful tools in all of science.
Wonderful. So the next question is, what does humanities have to offer to science? Science has been doing amazingly well. We've kind of discovered many new things. So why should somebody who is in science look at humanities at all? What does humanities offer? to
Yeah,
science?
good question. So humanities is a big umbrella, but I would say a few things. First of all, humanities, I think, is much better than science at asking the big important questions, right? What matters?
Hmm. Yep.
What makes life worth living? You know, et cetera. And sometimes science dabbles with those. Science will sometimes ask, how did the universe begin or something? That's a little bit different flavor of that question. Or sometimes science will ask, like in positive psychology, maybe they'll ask like, what makes humans happy? Or in economics, what makes humans productive or something like that. But humanities is really focused on the important questions, and I think that's something that often you'll find scientists toiling away at some tiny little problem, and hopefully that tiny little problem ends up being useful for something or becomes part of a bigger system that gets used. But a lot of it is actually just not focused on the things that matter. So I think that's one great inspiration we could take from the humanities. Another is that there are certain types of humanities, like philosophy, that I think give us really powerful ways of thinking. And this is something I often know. I don't know, psychology is somewhere between the humanities and science, but maybe it's slightly more on the science side. But one thing that I often notice when I'm reading psychology papers is that how much it would benefit from philosophers. Because what will happen is psychologists will be studying something like personality, right? And they'll design a questionnaire to measure people's personality, let's say, like the Big Five personality inventory, for example. Well, very often, if you read the paper closely, you realize they haven't really precisely defined what they even mean. Like when they say someone's conscientious, well, okay, they've got the scale, it asks certain questions, but what do they really fundamentally mean? And they'll kind of dance around it. And really, I think what's lacking there is philosophy. So I think there's a lot of ways of thinking that we can borrow from the humanities that actually can help us make better scientific progress.
Um, Next, let's look at what what technology has to offer to humanities, because I think we are living in a very special time where for the first time, with the computing power that we have and the networks that we have a capability of getting a lot of objective data about what human beings are doing and what is going on in their heads, and all kinds of data which was not available before, and an ability to process it. And the thing that does that is technology. So what is the potential of technology in dealing with in humanities?
Yeah, well, one thing is it's way easier to study human beings than it ever has been, partly because there's lots of passive data being collected, if you opt into having your phone collect your GPS or whatever, but we don't actually use that much of that kind of data. What we like to do is we like to recruit people for a specific purpose, and we can do it digitally, so we can get 100 people into our system, pay them an amount of money to participate, split them into groups, have them try different things, track them over time, see what works. And to that, it's just this incredibly powerful feedback loop, because we say, oh, okay, we want to know this thing, let's just go ask people. Or we want people to try this thing and see how it works, let's just recruit them in. And I'm making it sound a little simpler than it is, it's kind of complicated, but it's just so powerful, and it just really wasn't possible before. And sometimes we can answer a question in one day, a scientific question where in one day we design an experiment, recruit the participants, get the data, analyze it, and boom, we have it. And then you think about how fast you can move, and you can do kind of iterative science. So that's one thing that I really love about it. Another thing is that technology has the capacity to augment humans. And this began a long time ago with a human carrying a stick. In some sense, the human carrying a stick is more powerful than just the human in a certain way, right? It's like the human's augmented. Okay, they're just holding the stick, but still, in some sense, they're augmented. Now, we've got our cell phones with us all the time. We're augmented with Wikipedia and the weather and maps. And you think about how many augmentations that our phone gives us, but technology really augments humans. And so one thing we're really interested in is, can we build tools that then we put in your pocket in your phone, or put on the web that you can access anytime, that augment you, that help you do things that you couldn't do otherwise. And an example of this is, can we help you form a habit whenever you want? Can you, imagine the magic button that says, I want to form a habit now, boom, and you click the button? Well, we want to build that magic button. Okay, it's not going to be a magic button, it's going to be some tool or system, but that's the example of the kind of thing we want to do.
Excellent. Now let's take a couple of questions, and then people can go and discuss these in breakout rooms. People can discuss this kind of interaction between math, science, technology, and humanities. We are all focused mostly on humanities, but how do these three interact with it? So that's what we're going to discuss in the breakout rooms. Okay, so but we'll take two quick questions, one from Oksana and then one from Sanjay. Oksana, go ahead. Just a second, I need to let you unmute yourself. Yes, go ahead, Oksana.
Yes, great. Thank you so much, Spencer. It was very interesting. I just have a quick question. So it's, it's about questions that you have and tools that you apply, right, to answer the questions. And my first question was, how do you compile the list of questions? And maybe the second would be somehow the answer is, how do you practically apply the answers you are getting from the questions?
Mm-hmm. You mean the questions about what we study? Is that right? Yeah. So basically, what we're trying to think about are what are all the things that make a human behave the way they do? That's sort of the meta question we're asking. And so if you break down all the things that drive human behavior, there's many, many of them. You can start all the way at the base, and the base to me is intrinsic values. They're the things that you value for their own sake, not because they get you something else, but you value them fundamentally. And then on top of the intrinsic values, you've got your regular values. Your values, like you might value money, but you don't value money intrinsically, but you value it because it gets you other things, right? So you've got your intrinsic values at the base, then you've got your what are called instrumental values above that, like let's say getting money or things like that. And then what do you have on top of that? Well, you have your habits, you have your routines, you have your decision-making, tendencies, how do you make decisions. You also have your personality. And so we're kind of trying to decompose a person into all these pieces that influence behavior, and then we're trying to systematically study those different pieces. So that's kind of like where we're going long-term, is trying to see how we can improve those different pieces. Then on top of that, how do we actually go and put this in the world? Well, we run a series of companies and websites where we put these out. So if you go to clearthinking.org, you can try 30 different tools we made. They're all free. So clearthink.org, I recommend checking it out. In addition, we make an app for people with depression called Uplift. You can find it on the iPhone store. We make an app for people who suffer from anxiety called Mind Ease, 2 words, Mind Ease. It's on both iPhone and Android. So we basically make a bunch of products and we put them out there in the world to try to implement these ideas.
Wonderful. Next up is Sanjay, followed by Joe. Sanjay, go ahead.
Yes, so I completely agree that the sciences and maths together are essential for us to understand our world. They add to our level of understanding. So each are very important. So one of the things that I just wanted to add, and I wanted to get your take on this idea, is that most people in the humanities don't realize that the higher forms of mathematics are very symbolic. They don't even deal with numbers specifically. Mm-hmm. They involve concepts. For example, when we deal with fields or spaces, it starts to look very much like concepts in some humanities. So I just wanted you to elaborate on that, to help people understand that.
Yeah, it's funny. It's totally true. And I've joked with my math colleagues about how like you almost never see a number that's bigger than like 5, in your PhD. People think that a lot of math is about dealing with numbers, but I mean there are aspects of math. There's number theory, which is sort of all about numbers, and then there's data analysis where you're actually literally dealing with essentially spreadsheets of numbers. But a lot of math is not really about numbers. It's about structures. Everything from, for example, a manifold, which is kind of like the idea of a surface, right? Whether it's a plane or a more complicated surface. There's also the field of probability, which is around, studying, how do you model the probabilities of different things. Then there's fields like analysis, where you're studying functions, basically. So functions are things that take an input and produce an output, so you're studying those. So there's so many different areas. There's set theory, a lot of them just really, numbers are not the central role. So, but yeah, in terms of the connection to the humanities, I mean, the way I think about it is there's a bunch of, math is incredibly precise, right? Everything, when a mathematician writes something in a paper, they're referring to something just incredibly precise. It's not gonna be the same thing as, what someone in the humanities is referring to if they talk about a similar idea. That being said, there are a lot of metaphors in mathematics that are really powerful that I do think have direct applications. So it's not literally the equation that has the application in humanities, but the idea, the concept has the application in humanities. So an example of this in mathematics, you can prove that you should never, you can prove in a certain sense that you should never have 100% confidence in anything. And so that's a really powerful idea that then can be applied in life, for example. Or another example is in mathematics, there's this idea of optimization theory, which is the idea of how do you get more and more and more of a thing? And how do you maximize the amount of a thing? And there's a whole field of study about this. And then a bunch of the ideas from that actually apply in everyday life as well. When you're just thinking about, okay, how do I, make more time or make more money or more success or whatever. So I like to use those metaphors a lot, but they are metaphors and they're not literally the same as the equations.
Next up are Joe, followed by Anna. Joe, go ahead.
So some of the things that you had mentioned that you were addressing, like whether it be depression, anxiety, decision-making, I was wondering how you do your analysis. Is it, if you're looking to create something on a global scale, how do you account for systems within that, like economic systems specifically, and how they impact anxieties and things on those lines? Or is it just the human experience as a general experience is that you're analyzing?
Yeah, good question. So basically, the way I think about it, take something like depression, right? What causes depression? You'll actually find all kinds of people saying different things. You'll find some people saying, depression is really caused by your environment. If you put a rat in an empty cage, it's going to become depressed. If you give it like a cage full of other rats with like fun, toys in it, it will be happy, right? So that's what some people will say. Other people will say, no, depression is brain chemistry, right? Your brain chemistry has a problem, you take an antidepressant, it fixes it, now you're happy, right? Or you're happier at least. Other people say, no, depression is really about your beliefs, your cognitions, the thoughts you have and the things you believe about the world. If you believe you're worthless, you're going to become depressed. If you believe that you're hopeless, that everything in the future is going to be bad for you, you're going to become depressed. Other people say, no, that's all wrong. Depression is really about behavior, right? If you analyze a person's behaviors, you can see how they're maintaining their depression. Like, for example, they're ruining their relationships with their behaviors, or they're avoiding their friends, or they're not getting their work done, which makes them increasingly anxious and eventually makes them feel hopeless, et cetera. And so what's the deal with all these theories? Why are there so many theories? There's probably 7 or 8 or 9 theories of depression. It's because depression is an incredibly complex phenomenon, and all of these theories have an element of truth to them. The question we are trying to ask is, what can we actually make a difference in, right? So if we could change the whole economic system, that would be amazing, but we don't have the power to do that, at least not now, maybe someday. So, what do? Well, we do try to intervene on the things we can intervene. The pieces of that puzzle, they all come together. And what's interesting is that you could have someone that believes they're worthless, and you could treat them with their cognitions by helping them no longer believe they're worthless. But that person also might benefit from an antidepressant, and that person also might benefit from better relationships. So just because, the complexity of it doesn't necessarily mean that you always have to treat the problem the same way. There might be multiple ways of helping the person. So.
Thank you. So it's going to be Anna, Minnie, and Tanya next. Folks, keep your questions as brief as possible, okay? Anna, go ahead.
Thank you for giving me the opportunity. So my cell phone represents technology, math, and psychology united to create the most powerful addition ever. How do I train myself? What will help me to detach myself from my cell phone?
Yeah, because you have problems checking it too much?
Yes.
Yeah, I mean, many people do. I can relate to that. I check mine more than I should. Yeah, so there's a lot of different approaches you can take. One approach is you could have a certain time of day where you turn your phone off. You just say, I'm done. Phone ends at 9 p.m. Anything that happens after that, I do not need to know. I'll find out in the morning, right? So some people find that useful. It's kind of like with habit reflection, right? It's what is going to work for you may not be what works for other people. So all I can do is give you a few ideas, and you can say, which one of those seems like it might help me, you know what I mean, and pick between them and try them. And you might have to experiment. You might have to try 2 or 3 things. So that helps some people. Another thing that sometimes helps is people will have rules with their people they live with or their partners. So, me and my girlfriend, we have a rule when we're hanging out together. If we want to check our phone, we have to ask the other person, right? And that's great because it basically means we just stop checking our phones like when we're spending time together, when we're spending quality time, right? So that's another way to try to address it. A third way is that there's software you can get that actually will lock you out of whatever apps you find addictive. And you can actually set what time they operate. You can say, okay, I'm going to lock myself out between 10 a.m. and 6 p.m. or whatever, right? And so you could try that as well. So those are just 3 ideas, but really you have to think about what is most likely to work in your own life, knowing yourself. So. Yeah.
Okay, next up is Minnie. Minnie, go ahead.
Hi. So my question is that can we answer the major questions of humanity based on mathematics? Is it strong enough that we can create a model which can take the complexity of a human brain or the emotions as a variable? So I mean, I hope there is one, and I love mathematics, but I still not sure about that, if the maths is strong enough to, take human emotions or the complexity as a variable.
Good question. We certainly don't know how to do that. Humans are probably not smart enough to do that. Maybe some super intelligent aliens could figure out how to do that, but I don't think humans are smart enough to figure out how to boil down human nature to equation. But fortunately, we can make a lot of progress without having to do that, right? So for example, we can take a piece of human nature, we can study it, we can learn about it. Maybe we can't describe it completely with an equation, but we can learn about bits and pieces of it, and then we can use that to help people, right? Help them form new habits, help them form better goals, help them be happier, hopefully. So that's kind of the way I think about it is, yeah, we're probably not ever going to get to what you're describing though.
Excellent. Next up is Tanya. Tanya, go ahead.
Hi, thank you so much for letting me ask a question here. So I have how would cognitive functions and its systematic logic approach help with optimizing one's innate primary lifestyle without seeming too robotic or too controlled in that kind of way?
Yeah. So I'm not sure if you've ever looked at the book Thinking Fast and Slow, but there's this idea of system 1 versus system 2. And this is a model of the human mind. And so system 1 are all the things your mind does fast without you being aware of it, right? So if you say 2 + 2 = 4, right? You don't actually have to do thinking to realize that 2 + 2 = 4. It's sort of memorized, it's automatic. But there are many, many, many things our brain do automatically. For example, when we're talking, we often automatically answer without thinking about it. Or if we're catching a ball, we do it automatically without having to think about it usually. Things like that. That's a system 1. Then there's a system 2, which is kind of the slow, reflective part of the mind that uses working memory and it's effortful. So that would be like if you're adding 2 really big numbers, like 5,472 plus 9,261, you're going to actually be thinking about it, using your working memory as you plod through that. And you're going to have sustained focus and attention. So one way to think about your question is that there are many things in life that we need to use system 1 to do, because if we try to do them with system 2, the slow reflective system, it's awkward or slow. So an example is, imagine you're having a conversation and you're trying to use your system 2, your reflective mind, to control your body language. So you're like, okay, now I should move my hand up slightly. Okay, now I should smile. Okay, now, it's going to be very awkward. But here's the thing. When you're learning a new skill, you first have to learn it in system 2, in the reflective slow part of your mind. Then you have to practice it to get it back into system 1. Does that make sense? So even if you have a skill that eventually you need to get to this level of system 1 where it's fast and automatic and natural and not awkward and slow, you still have to first learn it in the slow, awkward, effortful way. And then eventually by practice, you get it smooth. And an example of this would be in martial arts. When you first learn a move, you're incredibly awkward with it, right? But you first have to understand it on a reflective level. You then practice the move, practice the move, practice the move. You get to the point where it's so smooth, you don't even have to think about it anymore. And now, while you're doing the move, you can be thinking about something else. You can be thinking about what you're eating for dinner while you're doing the move, because it doesn't require any reflection anymore. So I hope that helps.
Next up is Deborah. Deborah, go ahead.
Oh, sorry about that. I'm going to be teaching 4th grade next week, as a matter of fact. And I do a lot of for my master's degree on conceptual learning of mathematical.
Deborah,
expressing it in
you
a
cut out for a second there.
Deborah, you have problems with your audio,
sorry.
so I'm going to read out your question.
I'm sorry.
You put it very beautifully in the text, so
Okay.
I'm going to read it out. What would be your ultimate math lesson be to teach to 9-year-olds?
Yeah. Okay. So here's the thing that I think can help improve math education, which is really trying to find something that the students already care about that then you can use math to help them solve. So for example, if kids are into baseball, that's a great way to teach about percentages, batting average, just as one example. But I think a lot of times in math education, what happens is kids have trouble connecting with the material. They don't there's this abstract thing and they're like, how is this really going to help me? I guess the teacher or my parents think it's going to help me somehow, but if you can connect it to something that they already care about, I think that's just incredibly powerful. I don't know what 9-year-olds care about these days, so I don't know what the lesson should be, but it's just some food for thought.
Okay. Next up is Herb. Herb, go ahead.
Okay, I'm unmuted. I want to ask about individual differences and personal electronic profiles that might be made from the things that you've listed today that are important about human beings, the various characteristics and behaviors and so forth, which would be a growing body of knowledge, actually, to the person and to the field. Are you working on a kind of thing like that, and do you think it's desirable, and do you have any comments about it?
So, like building a profile of people basically about with information about them. Is that what you mean?
For the person to build it himself using the various tools that are available, or to have someone like yourself build it for them or with them.
Okay, good question. Well, first of all, I'll just say I think it's very important that anything like that be opt-in where the person's doing it voluntarily, obviously.
Yeah.
Second of all, so we do have some projects that are sort of in that direction. One is we've been looking a lot at personality. Personality is not everything, but it's a piece of human nature. You know, everyone knows, like, you've got your one friend who's very gregarious, and you have your other friend who's shy, and, you know, people differ. And you even see it in children. Like, it's amazing, you know, if you have, you know, 3 children and their, like, behavior is totally different from, you know, age 3 or something. You know, so that's one thing we're looking at is how can we characterize personality? And we're taking a very mathematical perspective, saying what we care about, what we're interested in is, can we help people predict behavior? Can we say, you might be at risk for, you know, getting in a fight with your friends. Maybe you should go do this module on how to avoid conflict or something like that. So that's one thing we've been exploring. Another thing we've been exploring, so I mentioned on our website, clearthinking.org, we have about 30 programs. But one of the challenges we have so many programs on there now, like people have trouble finding the ones that are most relevant. So we've been developing this idea of a path. So helping people like choose a path that's right for their life. That is kind of a navigation through the 30 programs where they're not going to hit them all, but let's say they'll hit 10 over a period of 2 or 3 months. That's customized to them. So that's another thing we've been exploring, but we're not very deep into that yet.
All right, so now we're going to go to breakout rooms just for 15 minutes, and then we'll come back. Spencer, I know it's 11 o'clock, so you're welcome to stay or leave, whatever you prefer. It's amazing. So this has been very good. So we're going to do breakout rooms for 15 minutes. Spencer, would you like to stay for 15 minutes, or would you?
I might. I'll probably come back in 15 minutes. Does that
Sounds
work?
good. Sounds good.
Okay,
that
great.
works.
Yeah.
So we'll be
Great
back in 15 minutes.
Great to chat with all of you. Okay.
All right.